On you.
I know. I was trying to figure. Oh, the stream is live. That's what I was looking for. All right, the stream is live. We have a bumper. Everything's great. Welcome to our KubeCon Wrapped webinar presentation here. I've got some folks from Flox. I've got Kelsey Hightower. So Michael is the founder and CTO, Michael Brantley of Flox. Morgan runs our DevOps area and actually runs a lot of the software that we build. I run engineering and I help with some other stuff going on in the company quite a bit. And Kelsey's a technical advisor for us. So, and he's of course well known in the Kubernetes community. So, we're just going to do a little bit of a recap as to what we saw at KubeCon, what Flox released, but then just generally what happens at KubeCon and things like that. So, with that, I'll turn it over to Kelsey and just say hello and welcome.
Hey, hello, welcome. See, I did those two things. So I'll be moderating a little bit. I don't know if we're going to do Q&A, but if any questions pop up anywhere, just throw them in the chat and we can address them. But I'll try to come up with some of the things that I've heard people talk about. So one of the things that before KubeCon starts is all the lead up. So all the people who sponsor KubeCon, who take a booth, the people you walk around and see, there's a ton of work that goes into getting ready to go to KubeCon. And so someone as a technical advisor to Flox, a lot of that work was centered around this idea. What if you could bring some of the fundamentals found in Nix into the Kubernetes world? And the reason why I'm starting with Nix, the Flox team kind of puts a lot on top of Nix to try to make it easier to use. But the first time people hear Flox and Kubernetes, they tend to go into question mode, like, what's that? And if you ever mention Nix, they're like, okay, well, what's Nix? And the way I try to explain to people that are familiar with the container world, so just to be clear, the container world, I think for a lot of people, allowed them to do what they were doing already, but more repeatable. So that Docker file really matched the way people were using make files or bash scripts to build and package software. So I can see why people are very familiar with Docker. But then what's the Nix model? So Kubernetes, a lot of people remember from the early Borg paper, or maybe you don't remember from the Borg paper. So the Borg paper is this paper from Google, and it talked about how Google managed servers at scale, which gives the foundational knowledge necessary for things like Mesos and then eventually Kubernetes. But what a lot of people don't remember from that paper was how packages were actually managed, how software was actually moved around. And it wasn't Docker images because that predates Docker. There's this concept around take all the dependencies you need, give them a clear identifier, and once you have a clear identifier, you just lay them out in the file system. I'm oversimplifying here for people. So if you want Python 2 and Python 3 and Python 3.1, you can have all three of those on a single server. For most people familiar with like RPMs and Debian packages, that's not happened very easily. And if it did happen, you're going to be in some weird file system foo like opt, Python 3, something, something, something. And then things get a little dicey. So in this world of npm, which is the package manager for the Borg days, you're basically laying out all the software, all of its version, and almost doing like reference counting. So leave it there as long as something needs Python 2, leave it there as long as something needs Python 3. So you can imagine how this goes. You now can have all the software in one place. The trade-off, you have all the software in that repository on every server. But the dope part about this is if you have two apps that land on that server, one needs Python 2, one needs Python 3, you're not going to have to download those two things over again. You can just keep sharing them if they all need that. That's the big difference from the Docker world. And I'm going to have the Flox team kind of jump into here about the big technical differences between these things. But I think the big thing you notice from a container pool or someone who uses container images a lot, when you're building Docker images, unless you understand how layers work and caching works and how things get pulled, what you probably end up with is huge images that are 2 and 3 gigs, and you end up pulling the same stuff over and over, even if it's already on the system. Or you get weird things like you just change your app and it causes the whole image to have to be rebuilt, which can take a bunch of time and just more stuff to move around. And so then you're asking yourself, well, if I have a 50 gig image, what's the best way to go about it? You can slim it, or you can try to think about this Nix approach, which is very similar to the way the Borg paper describes package management. I know, Michael, you've worked in a company, DH Shaw, that kind of did this in production. And I remember you gave it to me a demo for the first time. You're like, hey, Kelsey, it's a different way to think about software cataloging, very different than the way container people think about software cataloging. So maybe explain a little bit why Nix was successful in a company like that, and then why you want to jump out and start a company like Flox. And then we're going to walk to how does that show up at KubeCon.
So the Nix approach is not unlike what you just described there, in that software is built to live in a unique location side by side with other versions of the same software. But a little bit unlike what you described there, those packages are themselves built to depend upon other packages that are built the same way.
Hmm.
And what you end up with is this recursive dependency graph that takes your application all the way from that side by side version of Python that you want, all the way down to the libraries that they require, and with libc at the bottom. So what happens there is that whole collection of packages becomes bulletproof. It won't change. The behavior of that package won't change based on the operating system moving out from underneath it, and that collection of packages can be picked up and moved across operating system revisions. So you can take it from Red Hat to Ubuntu, and it'll work the same way. You can take it to any cloud provider in or out of a container. It always works the same way. So that was particularly useful at DE Shaw because it was able to essentially isolate the behavior of the software in production from what was happening by way of system administration in the background. It also fed right into their efforts to do cloud migrations. Companies out there will have had legacies of building software and administering them on Red Hat primarily, at least in the finance world. And they'll be struggling with how to take their internally developed software and get them out into the cloud. So those were the real advantages that DE Shaw saw there. In starting up Flox, what we observed is that not too many people were aware of these advantages of Nix, and we specifically started this up to bring that knowledge to the world and into other theaters of execution.
I kind of feel like I tell people what Docker did to Linux namespaces, Flox kind of did for Nix, right? There's a lot of great plumbing underneath there, almost like what GitHub did to Git. If you know all the low-level details, you can probably make it work. You'll create your own workflows. But for people that just kind of want to get in there and get it done, there's a usability aspect that I think Flox layers on top of Nix that a lot of people don't really realize that they're using Nix until they have to.
Yeah, I think one of the best comments I ever saw was somebody that said, "I've used Nix enough to know I'd rather use Flox," and that was like a really cool just testimonial from a user. But ultimately, we're wrapping it with a better experience, but we're also trying to kind of just put together some of these things in primitives. Like a Flox environment isn't a thing natively at Nix. There's things that are analogous to it. There's components of it that are near it, but we have a collection of packages, but it also has like hooks to start when you start your subshell. It also has environment variables you can either set or load from a secret manager. You have services that are kind of analogous to Docker Compose, where you can say, hey, this environment starts these 3 daemons when you activate it or whatever. And so like all of those tools and facilities are available in Nix, but they're not in one thing. It's a set of tools you would have to cobble together. Whereas we have a thing called a Flox environment that has all those things that can travel with you from development all the way through production. So yes, we're a wrapper with a better experience, but we also have some of our own kind of primitives in there that we're building up upon, which I think is kind of what Docker did as well. There was a bunch of stuff in namespaces and C groups, but then they kind of built a whole OCI format. So yeah.
Yeah, so for those that are like coming from that KubeCon background, when I got started with things like Flox, I actually just use it with Dockerfile. Like I'm familiar with Dockerfile. I like OCI images. Is how I distribute things. And so then what do you get? It's this idea that the goal of getting this reproducible build, there's so many ways people try to do this. It's not necessarily super easy. So I think Nix and Flox is like a cheat code, like just use that inside of your Docker file and we could have been done with it, right? So you package all this stuff up, you push it to a repository, and ideally you're done. But that doesn't necessarily solve the huge container image problem, and it also doesn't solve the I have 100 machines that need this 50 gig image problem. And I've seen people do crazy things here. This is where people are bringing back peer-to-peer file systems. People will do everything except for go to therapy. Like you don't necessarily have to try to use the same tool for everything. And I think this is where people started to take a step back. So if you're going to engineer new file systems, streaming file systems so that people can start streaming a multi-gigabyte image into the kernel so it can start loading. Once you start getting to this point, now you have to step back and ask yourself, okay, wait a minute. Is there something better to do in those scenarios? And this is where I think having the Flux environment start to explore this concept around a custom runtime. Now, a lot of people are like, oh, you're just Kubernetes hammer nail. Like, you could think of it that way, but you got to remember almost 7 years ago, by design, majority of people on the Kubernetes team that had a lot of experience with like running software kind of knew that you had to be a bit flexible at the runtime layer. For example, I'll give you one of the earliest examples. When I was at CoreOS, we built this thing called Rocket that allowed you to use systemd for a lot of the things that Docker does. So it's a direct competitor to Docker, but it kind of sat there, but it didn't have a hook into Kubernetes. And we built some weird workarounds to make this work. So the Kubernetes team decided to build a container runtime interface. And it allowed you to say, look, we could treat a VM like a container. So if you want CPU level isolation, instead of you having to teach all of Kubernetes about this new runtime, you would just hook it in the right spot and just use this particular framework SDK to say, I know how to bundle my software, I know how to bind to an IP, and I know how to keep running. So once I can create my own sandbox, whether that's one or more containers like pods do, you can just integrate into Kubernetes world. And so the team over at Flox is like, hey, that might be a place where we can have people have that one-to-one Flox experience. And I'm going to bring in Morgan here maybe to explain to people what this one-to-one Flox experience feels like. Because if you're a developer writing software, there are a lot of those developers that just use Flox to kick off software development, and they just want to hold that environment from end to end.
Cool. Yeah, I think I'll maybe flip over and just kind of show a little bit, and I can kind of lead to the package concept that Kelsey and Michael were both talking about.
I love that. Show don't tell. So are we sharing screens? Look at that.
I mean,
a man of confidence.
For something like this, you got to be able to see it. Yeah, it is a lot of confidence. We'll see how it goes. All right. So, I have like a toy example that we'll talk through. I have like a small Go application. And so what I have here is like the source code, and then I have a Flox environment.
Make
so
your screen a little bigger.
How
Or
about
yeah,
that?
yeah, and you could probably make that window full
that?
screen. There you
How
go.
how about
Now
that?
you're winning.
Now we're cooking with gas. All right. So I have a Flox environment here, and I'll open that up real quick and show you that I have my development tooling for the Flox environment. So like I have Go installed, and then a couple other libraries, and then I also have so this application is it prints quotes, and it uses Redis to store the data, so that like you can share quotes between multiple replicas. And so I have like the Flox environment I used to develop it here, and then I also import like a existing environment for Redis just for my development workflow, so I can do testing. And then what I can do from this environment is I can do my work, right? Like I can work on it, I can build it, but I can also take it from here and then kind of push it into that production concept, into towards Kubernetes. And so I'll kind of take you guys through that. So the first thing I can do is as part of the Flox environment, I have build instructions, and so they're kind of grayed out right now, but essentially the build instructions are like the same as you'd expect them to be for building a Go application. There's just one thing that's a little bit special. In this case, to be able to package something as part of a Flox package, we build it and then we copy it to a special directory, which tells Flox like, hey, this is the thing that I want to build and ship to run. And then from there, I just run Flox build, and what I end up with is a package, which you can see like the output of here, which is my application. And like Kelsey and Michael were talking about, like at this point it's down to like sensible packaging, in the sense that everything I create and build like this goes to this single place in my file system, the Nix store. So at this point I have a package that's something I can that I completely describe with this hash. So this is like purely unique, which means if I like ship this to my production environment, I don't necessarily need to know a whole, like a base image, or have to have a lot of context. I as long as I have this hash and I have the information about what goes with it, like I can just ship this in lieu of an OCI image with my entire application. So from here, what I would do is I would publish this. And so in Flox we have a construct called Flox Hub, which it's similar to Docker Hub in the sense that it's a place for you to take your applications and then host them for them to be consumed as part of a deployment. And so in this case, I would run Flox publish, and then I end up with my package, the one I just showed you that unique hash for, hosted here. And so at this point, I took my development environment, I made some software, I wrote the build instructions, and then I built it, and then I published it to a package registry, not an image registry, but this is just the package and its dependencies. And so then to ship it to a production environment in Kubernetes, I create a second Flox environment. I'll make my font size a little bigger. And so before I had the development environment, right? So you could think of it maybe analogous to a dev container in the sense that this is all the tooling I need to be able to work on this thing and to build it and to package it. But ultimately, that's not the environment I want to run production. Right? I want to run just my application. But so now what I do is I create a second Flox environment, and I'll open up the definition real quick. Inside of this environment, the only thing I include in it is my application. And so you can think of this analogous to like a Docker file that I would put like a single Go binary in. But in this case, I'm not going to build an OCI image. The only thing I'm doing here is I'm saying the metadata around this Flox environment completely describes what I need to be able to run this application. And so what I can do is I can take the definition of this Flox environment, and I'll show you the pod spec in a second. But essentially, what I do is I give that to the Flox container gshim running on the node, and I say, hey, realize a container for me, but don't use OCI image. Instead, use the definition of this Flox environment and go get the package. And so instead of pulling a base image that has like operating system and a bunch of other stuff, I'm instead telling the node, just go get the package for me that I need to run. And then it'll realize the container image, or it'll realize the container out of that. So there is no image. It'll realize the container file system out of the package definition. So I take this environment and then I publish it also to Flox Hub. So in this case, you can see again, this is the thing I'm going to realize the container out of, and it is just one application. It's my app, and you can see the name of it is Flox/quotes app, which will be relevant in a second.
So let's explain to people a little bit there. So if you were just doing this with the server, no Kubernetes, and you took one of these packages, the assumption is that this will get moved to the server, and when people wanted to run something, you do what you would normally do on a server. You would just point to that binary, and it has all of its linking to if there were external dependencies, and it would just run like any other thing. And so you making this is like, hey, there's a package that lives somewhere. In the case of Kubernetes, since everything has to be a container, whether it needs one or not, the concept of realizing a container from that is more like a snapshot, meaning we're not going to go and take the entire file system from the node and inject it into the running thing. That would be insane. Ideally, what you're doing here is saying, hey, here's the configuration you'd need. So when you create that container just for Kubernetes to be happy, go pull these exact bits, put them in a certain place, and then hand the results off to Kubernetes via an image, aka a file system, if you will. And then Kubernetes was like, I can't tell whether you pulled this from Docker Hub or created it on the fly. Either way, I'm going to run it. And so this is the work that was done by the Flox team to make this integration kind of seamless.
Yeah, exactly. It's at the end of the day, Kubernetes just wants a container with some stuff in it to run. And so, whether you get there with an OCI image or whether you get there with this, like it's you're giving Kubernetes something to orchestrate. And so we're just doing it in a little bit more efficient way using.
I guess technically Kubernetes wants a file system, and it typically composes a file system from a container image. So for a lot of people that may not be aware, the container image is there for transportation reasons. Once it's transported, it's actually deconstructed, put it into a cheroot, and then used from there. You're just skipping these extra steps by saying, hey, why go download 50 gigs when the majority of it's already on the machine? So that gives you a way to kind of pre-populate things. I just want to interject there because this debate isn't containers versus like Flox or Nix. We're talking about a technical way of distributing bits around and common interfaces for runtime to leverage the bits and only the bits that it needs at runtime.
Yeah, exactly. And that's a good clarification because ultimately at the end of this, like the container we create like has all the same benefits of a typical container, right? It's the same isolation, the same ability to do neat networking things. Like it's functionally equivalent, other than the fact of how the file system of the container is actualized.
Yeah.
Um,
This might be a good point to interject, though. That one of the things that the artist, the Kubernetes artist, will be to construct their containers in such a way that they get cache hits for the layers of the containers that they do. And that is an art. And if you have two images of differing origins landing on the same node, the chances for a cache hit for the layers are not that good. Conversely, though, if you're constructing your runtime from Flox environments and they're entirely dissimilar, they're both likely to have a copy of libc in it. And so there is a chance, given that there's finer granularity at the NIX package level, for there to be cache hits. And so that just improves the efficiency of containers that are assembled in this way.
Yeah, for all my Docker people out there, you may remember when Docker added this ability to squash a container image as another step. So you would do all the things you would do to package, but then there was another section where you almost created this kind of net new image that would finally. So I remember having this saying, ship apps, not dev environments, to production. So what people were traditionally doing, just shipping all of this stuff in their base images plus all the things they piled on. But once Docker had this kind of squash all the layers concept where you could just cherry pick the things you needed and squash it. The problem is most people were not good at cherry picking, right? Pulling Python over without all of its dependencies results in an app that doesn't even start. So I think Nix is just saying, hey, let's just be explicit from the start. And then you don't have to think about cherry picking so much because you already have a resolve dependency graph that just can move around versus you guessing.
Yeah, exactly. Yeah, so to wrap this up, I kind of want to show what it looks like to take that Flox environment that we defined and then move it into the cluster. And so this is a typical like deployment spec. And I'll show like there's three parts of this that make it interesting. The first is the runtime class name. So like we've talked about kind of leading up to this, like the mechanism with which this operates is a custom container runtime shim that runs on the node. And so you specify the runtime class in the pod spec, and that is what tells Kubernetes to tell the kubelet to tell container DA like when you create containers, like use this instead. And that is the thing that actually constructs the container file system out of the Flox environment. The other piece that's interesting is the annotation that tells you what Flox environment to use. And so as a reminder, like going back, ultimately the thing that I created was the Flox environment containing my package that I want to run in the cluster. And this is just a reference to that same environment name. And then the third thing that's interesting, I wish I had it pulled up actually, but is you do have to provide some OCI image to start with. And so what we provide is a 49 byte, just like it's an empty image. So that provides that's the required foundation, but ultimately our shim is what constructs the container file system on top of that out of the Flox environment. And so from there you end up with a pod with a container in the cluster that contains it contains the contents of the Flox environment. So what is your application and what is needed to run it, and that's pretty much the short and long of it.
Awesome. So we get to KubeCon, we make this announcement, and people have questions, right? And so maybe we'll jump into some of the questions. So the thing about KubeCon, if you've never been, I know Morgan, this is your first KubeCon.
Yeah.
KubeCon went from a community created thing to this. I would say at this point it's a huge trade show. I think the Linux Foundation does a decent job of trying to balance huge trade show with like 10,000 people plus with like the meetup feel that you have to go look and find, right? So there's evening events, there's all these things. But there's all these talks, there's all these tracks. But Morgan, this was your first KubeCon. Maybe give people a little bit of a view of like how you compare KubeCon to a meetup or something like reInvent, right? Given that this is your first KubeCon.
I think for me, like it felt like a bunch of small meetups almost. Like I think some of the best conversations I'm actually remembering the last day. I just sat down to eat lunch and I ended up sitting with a guy and like we hadn't met before and we talked for 20 minutes just about it's fun to meet other people who do what you do and who can kind of relate on the same things. I think that's one of the big highlights. Being able to hit some of the booths, like I got to meet people who developed projects that I use on a daily basis. So that was it was really awesome to kind of have like almost a buffet of being able to like talk to people and build relationships.
What would you say the big theme was at KubeCon, right? Like, every year there's always a theme. All right, I think I know what the theme is, but what did you think the theme was?
I mean, I think everybody had some AI thing to talk about. I think for me, it's a split between AI and observability. I feel like there's always a lot of discussion around observability. Maybe mixing those two together. I think that those for me, there's definitely a lot of different like database companies or that kind of thing. But that all kind of even goes back to AI, right? Of you gotta have data to feed and train your models on. But yeah, definitely a mix of AI and observability. I think were probably my big like the big takeaways, at least from the floor. So
Michael Stanky, what kind of questions did you get? You're working the booth. We did a book signing. We had a nice long line on the last day of the event. What kind of questions were people asking?
I think so. Our big tagline was Kubernetes Uncontained, which was kind of the marketing framework and pitch for what we were doing. And some people just came up and were like, "What does that mean?" And they were just had some thought provoking conversation around it, which is great. And so you can kind of explain a little bit about the round trip time on a lot of times when you build a Docker build a Docker image, the first thing you do is ship it up somewhere just to pull it down where you want to run it, and it was like, well, this is extra steps. And some people are like, that doesn't bother me at all. And other people are like, that's a big pain in my butt. And I would like to change the way that I work. And so you would talk about that. Other people were interested in kind of the Kubernetes runtime, but not that interested in Nix. Other people were very interested that we were built on Nix and had brought, like a business workflow around it. And that was exciting. So I would say that a lot of our conversations ended up being 15 minutes or 20 minutes at the booth, which is always, that's a deep engagement for a trade show floor. And for us to have those conversations where people are asking, wait, but how does that work? Or what are you doing there? Or what's this runtime class? Or wait, when you have an image called Flox empty, what does that really mean? And it's like, well, it's dev null in a container. And there are other things where people were just asking tons of questions, and then even getting into kind of the primitives of Flox of like, well, how would service management work if I was doing this in a developer environment and things like that. And so, Morgan was up at the keyboard all day, just demoing anything that people asked for. And, and there was definitely some skepticism as well, which I kind of knew that when the whole world has been built around this container concept, and I think everybody's really familiar with it. When you do something that's a little different, there's people being like, why would I ever want to do that? And that's fair too. You can do a lot of the things with traditional container tools that Flox gives you out of the box. It just takes a high degree of effort. And we're saying, hey, you want a software bill of materials to come with you? We can do that. In fact, we can't not do it. And you want completely declarative, setups of your environment. We do that. Like that's how it works. And so some of that people were really excited about, and other people are just like, okay, seems interesting, thanks, and that's fine too. I don't expect everybody to adopt, a new piece of technology instantly. So.
I hope Kubernetes doesn't lose this extension experimental layer, right? This isn't OpenStack. This isn't Cloud Foundry. Kubernetes was supposed to be a little bit more like Linux. A lot of the interfaces in Kubernetes don't assume very much, like the CNI interface, the container networking interface. Cloud providers integrate that with VPCs and their networking fabric, which you don't have on-prem. But if you go on-prem, you might be a Cisco shop or a Juniper shop. And in those cases, you may integrate with more traditional networking things that you actually have. But the fact that anybody, any provider, anyone with a new idea, overlay networks, you name it, can come into that layer and present networking to Kubernetes, and then Kubernetes just attempts to hold the abstraction all the way through the stack so all the other tools work. And the same thing for runtimes. When people are like, look, we'll never get the kernel to be secure from a pure isolation standpoint, you saw people bring in things like gvisor, which implements kernel space and user space to try to intercept those system calls before they can cause any harm. Or people who said, hey, let's just use VM level isolation, and then we got micro VMs, and now there's WASM, and now there's things like Flox. So I just want to make sure people understand it's not a either or. I think you may touched on this, Michael, quite a bit in our previous discussions. You can use both at the same time. Maybe you have an ecosystem of people that just like we just use certified Docker images from third parties, but we have a few teams that are all in on Nix, and we just want to allow them to keep using Flox or Nix all the way through the stack. Like, kind of here's your chance to do that. And Kubernetes was designed to have multiple runtimes. That was kind of one of the highlights in Morgan's demo, which was you have to tell each workload, unless you want the default one, which runtime to use. And that gives you this ability to mix and match. So this is one of those things that you can try it out side by side. If there's any real world benefits as a platform engineer, then you get to make that decision. So just want to remind people that is the design of Kubernetes, and it was purposely done so we could do things like this.
Yeah, and one of our cool demos had containers running side by side in the same pod with a Flox environment, like, kind of the sidecar pattern going, because it was like, this is the real world. This is how people want to do things, and we want to meet people where they're at. If you already have a bunch of investment in the way you're managing containers and the workflows around it, I don't want you to have to stop doing that to start, touching any of our tooling. It was more like, well, if you have, your perfect monitoring setup in your sidecar already, please just use that, and we'll jump in there with our Flox environment. So
I think a lot of next steps for people, go find people, whether it's on the Flox team or the Nix community, or go to a meetup. What I want platform engineers to do is bring a notepad with them, and I want you to actually sketch out how you think packaging works. Because what I've noticed is a lot of people don't realize what they're doing. So I'm going to give you an example. Maybe you go buy a base image from somebody that promises to prevent CSVs or CVEs from ever occurring. And that's kind of possible depending on how they do it. So you have this really bulletproof base layer. Let's call it for Ruby. So you take this Ruby base layer, and guess what? It doesn't have all your dependencies in there, because that would be impossible to forecast every dependency someone would need. So what you do is you take the base image and you just start adding things until it works for you, right? So you may get cute and just have one layer just for all the Ruby dependencies. So Ruby gems install the internet. So you have all this stuff on your system. You probably don't know how that works, but that's okay. So now you're bringing in all these libc dependencies for libxml, whatever. So you got that layer, and then you start adding your stuff. And then your stuff occupies a whole nother layer, and then you're like, all right, I'm not sure what's in there, but I know it works. So that satisfies this kind of reproducibility standpoint, but not necessarily what we mean by reproducible software. And then we go as an industry and we reverse engineer what we just put in the black box. Meaning we scan all these layers, we get all these red, yellow, green reports, we try to make them turn green. How? By upgrading all the packages. We still don't know if they work, but we know they turn green. And then in order to get that SBOM, so if you want a software bill of materials, typically what we do is we add additional tooling that tries to guess what those things are. Now, if you're using a package manager, it's a little easier to guess because they leave breadcrumb trails behind. But a lot of people are actually pulling things straight from GitHub in source format. There is no release. There is no metadata. And in those scenarios, who knows what the hell you're getting? And the thing that tends to break is that one container image goes through this process on Wednesday. The other image goes through this process on Thursday. They are not using the same libc. Or they could be. You don't know. So in that world, we did a lot of work to get to this point in 2025. There are some people who say, what if we rewind the clock back 20 years and we went down a different path? What if we decided that all software should have a unique identity, a unique hash, and a resolution chain like the one we've been talking about for the last 20 minutes? What would the tooling look like from here on out? RPM would be different. Ruby gems would be different. I would argue virtual inf and all that infrastructure wouldn't exist. We wouldn't do it. We would say, if you need something, go put it in the content addressable store on the system that will consume it. Synchronize that across your entire fleet, and then compose your file system at runtime. This is the whole chroot thing, and it's kind of what VMs do if you think about it. There's these VM images that take a snapshot and then they start themselves. And if you want a new one, you have to build that collection all over again. So the thing I want you to think about here is maybe it is okay to revisit this layer, because I don't know if it's a solved problem, because when AI came on the scene, it had us all revisit this. Because when you start going from like a 100 megabyte image to a 3 gigabyte image or a 50 gigabyte image, all these things start to have a real challenge though. So I'm going to challenge the community with that. That's honestly what we do at KubeCon. Honestly, you go have these hallway track conversations. You may go watch a talk. You swing by the Flox booth and you have all these questions. That's what KubeCon in our original design was designed to do. New ideas all in one place. And you just ask people, how did things work? How should I be thinking differently about this? So I encourage you to do that. to go revisit this layer, go give it a try, and like give people feedback. This could be a dumb idea, but we're not going to find it out unless real people who have real challenges actually try it and give more than knee-jerk reactions because they just don't think this is the right way of doing things. I got to drop in about 10 minutes. Another team can stay on and answer a lot of questions. I'm probably going to roll across the team. What's next? We kicked off this Hacker News thread. It kind of died and went nowhere. Then it had a resurgence like this weekend, which was dope, right? People started asking questions. I know Ron with his new child was on there asking questions. I saw different people from the team jump in, and it seems to be a lot of curiosity. Also, seeing people from the Docker community like Justin Cormick, right, one of the OG people from the Docker community, also opining around why Docker works. And he didn't dismiss this approach entirely. He explained why maybe people should probably be open because Docker has some fundamental challenges that get in the way of some of the things we've been talking about.
Yeah, I mean, I think what's next is we want feedback. Like, we want people using this. We want people jumping up and down with it and telling us, hey, I love this part, or this thing doesn't work quite right. Could you rename this? It's not clear for how I think about it in a mental model. We want real world feedback on it. And, we're using it internally, and we will continue to use it internally. But I'd love to see a bunch of other people, just trying this out. And if you put it in your lab or you put it in your I guess lab EKS cluster, or whatever you're doing, please check it out. And if you need help with us, we have a community Slack. We're happy to hold your hand a little bit and help you walk through it, or explain things, or just work with you on it. I think right now it takes a little bit for people to get to this point where they want to use the Kubernetes runtime with Flox, because you have to understand a little bit about Flox first. And as Morgan showed, you create an environment, and Morgan went through our ideal workflow where you create an environment, you package something up, and you create a second environment that I think is more production oriented that consumes that package. There are some other shortcuts you could take in there where you could just run the exact same environment from development in the Kubernetes environment. That is totally doable. It might be the right way to kind of just learn the interfaces a little bit and learn about it. But outside of that, we're really looking for feedback. I think we're also starting to expose some more of those things on Flox Hub, where like you'll be able to click a button and get your entire software bill of materials with all the environments you're publishing, like just out of the box, because we have all that information in the back end. It's just a matter of, what's the workflow and the interface that we want to give to the user on that. So that's coming in, weeks, not months. And then we also have so many ideas on things we want to do, just because you have the prominence of where every piece of software comes from. We just have an ability of doing basically security and understandability by construction and not by scanning post facto. And that just changes the entire conversation you can have around software delivery. So ultimately, if you're looking at how are you delivering software right now, and you're thinking, do I want to relook at this because of the maybe AI injection into overall software development lifecycle, it might be a good time to think about knowing where everything's coming from as well, because I think that's a good thing. So if we can piggyback on an AI catalyst to relook at your SDLC, we're happy to do that.
Yeah, I predict once people realize the journey to reproducible software, maybe we did get off track at some point. So whether you want to bundle this reproducible environment in the Nix store or an OCI image, we're going to have to get back to the world of being explicit. And this reverse engineering approach, it's really expensive. I don't think people understand how much compute globally goes into scanning software every day to produce red, yellow, green reports. I'm gonna be honest with you, it don't matter, because the vulnerabilities that hurt you don't turn red, yellow, green. They just get exploited. And so maybe, just maybe, we can just calm down on the theater part of software management and do the engineering part of software management and just be explicit. This is what I want. When you bake a cake, you're kind of explicit, right? You don't put on a bandana and go in the refrigerator. It's like, all right, this feels round. This must be salt. This feels like an egg. It must be an egg, and put it in there. Bake the whole cake, and then try to have a chemist decide what's in there. Like that sounds crazy, right? For baking a cake. Why are you doing this with software? So I really do think it's time to probably just figure out whether Nix is the right tooling or not is a separate discussion. But I just know reverse engineering our way through this is probably insane. With that, I'm going to drop. So my prediction is when people actually understand this problem hands-on, it's one thing to read about it. It's one thing to go with the flow. but it's another to really see a solution and wrap your brain around it and say, oh my God, what was I thinking? And that doesn't mean all the other tools go away. I think what that means is all the other tools just change their inner workings to leverage this kind of approach and then distribute it in a way that makes sense. All right, I'm going to jump out of here. Hopefully you guys stick around for the time, but thanks for having me again, team.
Yeah, thanks so much, Kelsey. Appreciate it.
Thanks.
At this point, if there's questions, please throw them in the comments area, and we're happy to jump in and answer them. So that would probably be, I guess that's the call to action from the audience. Overall, let's see, one thing I was going to share while we're waiting maybe for a couple questions was, let's see if I can figure this out. Screen sharing.
Well, while you tee that up, I'll just I'll expand a little bit about something Kelsey just said about building software to a unique location that's basically based on where it came from in the first place. There's a subtle implication of that, which is that the things that you create are essentially immutable thereafter. They're very well defined. Once created, they don't have to be created a second time. That makes them easily replicatable. It opens out some opportunities in software distribution that were very, very hard in a world where software could be changed after it had been laid down on disk. And so, it opens up opportunities for performance and optimization that just weren't so easy before.
Yeah, all I wanted to do was kind of pull up this image because containerd does require a container to basically spawn the process that it's going to run. This is the container that we use by default in all of our pod specifications. And the reason we do this is because it's the smallest thing that we could possibly use. And if you can see in the description, it tells you literally how we make the container, which is we put dev null in a container. And it probably won't get updates because I don't think modern versions of dev null will behave differently than previous versions of dev null. But outside of that, it will fail many security scanners because there's not even the basic files that it expects or anything because it's literally nothing. But it was kind of a fun, pithy thing to show off, and I just wanted to bring it up here. So
yeah, it would be 0 bytes if not for compression header.
Oh yeah, is the 49 bytes just the compression header? Okay,
it is. Octal 377.
Yeah. Yeah. Well, if there's not questions, I haven't seen any questions pop into the comments. I think we can end it. But I do appreciate everybody's attendance and coming in. And if you haven't checked out our Kubernetes offering, please do. And if you have feedback for us, we'd love to hear it. Even if it's, hey, this doesn't make sense to me and it doesn't work for me. We do want to hear more about it. So, yeah, thanks a lot. I guess if you're going to reInvent, we will be there. If you want to talk to us a little bit, we won't have a booth, but we will be around. Oh wait,
we got a question. We got a question.
Is there any benchmarking? I will say that we've done some internal things where we were basically trying to figure out startup times and things like that, and we definitely can have advantages under certain workloads, under certain conditions. If you're starting with nothing on disk from Flox and nothing on disk from the container image, the performance difference is basically, are we better bin packed than they are because we have exactly the chain of dependencies you need and not the extraneous distro stuff that you might have in a container. We don't start from like an Ubuntu base image or anything like that. We start from literally what program are you going to run and what is the dependency chain all the way below it, which is in Nix parlance called a closure of software. And so we just give you the closure of the software that you need to run, and that's all. And so that can be a lot smaller than a base image, but it also depends on what base image you choose. If you're choosing a very tiny busy box type image, it's a negligible difference. The big difference comes usually in kind of the rework or redeployments where certain things are updated in a Docker file. When you go and run a Docker build, basically the first line that you make a change on, everything below that, every layer is new. And so all of those layers have to get shipped. Whereas for us, you can kind of think of each package as being its own layer and it's independent. And so only that package that gets changed is what's shipped. And so if you have a collection of, a couple dozen packages and you only change one, well, then the other 23 are going to stay exactly the same and you only ship the one that has a delta. And so that's a big performance increase. Ideally, that's around things like, AI models where you have those giant packages that might be a 10 gig download or things like that. that's where you'll start to see those performance increase pretty noticeable. I don't know, Michael, do you have anything to add there?
The only thing else I'd add is that, yeah, the unit of caching is that Nix package, which is a smaller, more granular unit and can be shared by disparate container workloads, Kubernetes workloads over time. But we also at Flox, we're providing a sort of happy path for the use of Nix, and with some opinionation around the use of Nix packages pinning. So what that means is if you're a company using Flox across multiple projects, multiple departments, we'll help shepherd you along the lines of using that same Nix package revision so that you will have more of a likelihood of a cache hit there over time.
Yeah. All right. Well, thank you, everybody. And yeah, as the chat is saying, there is a Flox community Slack. I think the link was shared earlier at 37 past the hour. So feel free to go sign up for the Slack if you're not already there, and if you are there, hello, I'm there too. But thanks so much. And we'll probably do another one of these, sometime in the somewhat near future. But as we have more stuff to talk about and dig into. But thank you for your attendance. Thank you for attention. And we'll call it a day. Cheers.
Thanks, guys.
Wow.